Here is the second example if you chose to continue on to this video. Running at a speed of 2.7 meters per second, it takes Tom 7 minutes to get home. How far is he from home? So let's just draw a quick diagram of Tom running. List what we are given. And I did not do this in the last example because we were given a bunch of information. This is more of the traditional way to solve a problem, and you will see this format in the problem solving guidelines. So we are given that his speed is 2.7 meters per second. The time is equal to 7 minutes. And we want to find how far he is from home. So we are looking for his distance x. The only equation we have that relates these three things is speed equals distance over time. One thing that we want to do first is get the variable we're solving for by itself, so that would be the x. So isolating x, we get x equals speed times time. Putting in the numbers that I was given would give me an issue, because if I look at the units, meters per second and minutes are not the same units. So we need to convert these minutes into seconds. So 7 minutes, there are 60 seconds in 1 minute, so 7 times 6 is 420. So this would be equal to 420 seconds. So therefore x equals the speed, 2.7 meters per second, times time, 420 seconds, which equals 1,134 meters. So how far is Tom from home? With 2 sig figs, Tom is about 1,100 meters. Fairly simple example. The only trick here was making sure that the units again matched up. You could have converted to meters per minute, but that's not a unit we would ever use. In general, if you're given time, you want to get it into seconds. Okay, let's look at example 3. Patricia drives from her house to school, which is 5.8 kilometers directly north. She then drives from school to work, 2.1 kilometers directly south. Finally, Patricia drives home from work. Determine the distance and displacement for home to school, school to work, work to home, and then the entire trip, home to home. So if this is home, her house, she starts by driving 5.8 kilometers north to school. Then she drives 2.1 kilometers south to work. Finally, goes back home the rest of its distance. So part A, home to school. Her distance x is equal to 5.8 kilometers. Her displacement, she is 5.8 kilometers from where she started, so displacement will also be 5.8 kilometers. Displacement in this case is positive because she's traveling north. North is up. Part B, school to work. Distance would be 2.1 kilometers. Displacement, she's traveling south, so this would be negative 2.1 kilometers. Part C, work to home. So she's starting from work, which is 2.1 kilometers below where school was. So to figure out what that distance is, we have to figure out how far she is from home. 5.8 minus 2.1 would be 3.7 kilometers. This displacement is from work to home, she's traveling south, negative. So delta x is negative 3.7 kilometers. And finally, for part D, for the entire trip, her distance from the time she left home until the time she got back home. 5.8 kilometers to school plus 5.8 kilometers back home, so 5.8 plus 5.8 is 11.6 kilometers. Her displacement for the entire trip home to home. She starts and ends in the same place. This would be 0 kilometers. Another thing you could have done was add up all of your displacements from parts A, B, and C. 5.8 plus negative 2.1 plus negative 3.71 equals 0. To get the total distance, we could have also just added up the distance from each leg of the journey. So 5.8 plus 2.1 plus 3.7 gives you 11.6 kilometers.